Let's see this question 39. Consider the following pseudocode. This pseudocode has been given L1 to L15. Which one of the following options correctly specifies the number of basic blocks and the number of instructions in the largest basic block respectively? So here we have to find out number of basic blocks and number of instructions in the largest basic block. At first I will have to find out the leader, then I will find out the block, and then the number of elements inside the block. So this is the steps to find out the leader. Identify the leader first statement. So this is leader. I just highlight all leaders. L1 is leader. The address of conditional unconditional go to is the leader. So conditional unconditional go to address, target location go to L1, L11 is leader, L4 is leader, L3 is leader. Okay. Immediate next line of go to is the leader. So immediate next line of go to L10, L13 and L15. These are leaders. Now between leaders there will be block. So this is block 1, this is block 2, from here to 9, block 3, block 4, block 5, block 6, block 7. Okay, so total 7 basic blocks and maximum number of instructions. Largest basic block, so this is largest. How many? 2, 3, 4, 5, 6. So correct option is 7, 6. There are 7 basic blocks and till L4 to L9 the number of instructions are there, total 6. Okay, D option. Next, see this one. Consider the following two threads T1 and T2. Two threads T1 and T2 has been given that updated two shared variables A and B. Assume that initially A equal to B equal to 1. Though context switching between threads can happen at any time, each statement of T1 or T2 is executed automatically without interruption. So T1 is A equal to A plus 1, B equal to B plus 1, T2 is equal to B equal to 2 times B, A equal to 2 times A. Which one of the following options list all the possible combination of values of A and B after both T1 and T2 finish execution? Okay, so context switch can happen at any time. So I just rename these instructions A, B, C, D. So what are its possibilities? First possibility is A, B, C, D. Next possibility is A, C, B, D. Third possibility is A, C, D, B. Is there another possibility? See, A, B, D, C is not possible. Like this, if thinking A, B, D, C, this is not possible. So A, B, C, D, A, C, D, B, A, C, B, D. Okay. Next, if T2 starts, then C, D, A, B or C, A, B, D or C, A, D, B. So total 6 possibilities are here. So for each possibility, calculate the value of A and B. So for A, B, C, D, see, I see at first for A. So A, D, after A, D is happening. So A will be initially 2 here and then 2 times of A. This will A become here 4 and B will be See, for B, what is happening before? B, then C. So at first this will be 2, then 2 times it will become 4 for this C. A, D, same order. So A will be 4 here. For C, after A, D is happening. But here C, B, C, here now C, B. So C, B will be 2 times 2 plus 1, 3. So B will be here 3. Here A. So after A, D is happening. Yes, after A, D. So here A will be 2, 2 times 4, and B will be CB. So C, CB 3. After CB, after CB. This one A. And for A, at first D, then A. So 2 plus 1, 3. And B will be, for B, what is its order? A, D remove. CB. So for C, it was 2 plus 1, 3. Here A. C, then B. After CB, so 3. After A, now D. CB. Sorry, AD. So this is here. See, for A, at first A is happening, then D. So this will be for A at first 2, then 2 times 4. And for B, C, then B. C is 2 times all, 2 plus 1, 3. So B will be 3. Here, what is order of A and D? A before D, then. So A will be 4 and B will be C, then B. 2 plus 1, 3. So what are the value of A and B? See, 4, 4, 4, 3, 4, 4, 4, 3, and 3, 3. Others are repeating. So 4, 4, 3, 3, 4, 3. This is correct option, A option. No other option is matching. So A option is correct answer. Next, see this question 41. An array is heapified. Which one of the following options represents the first 3 elements in the heapified array? So this array is given and we have to heapify this one. Which one of the options represent the first 3 elements in the heapified array? So it has not been given either max heap or min heap. So just try both. At first make a tree of this array 82, 101, 90, 11, 111, 75, 33, 131, 44, 93. So let's try it first. Min heap, is it possible? Min heap? No, because first 3 element it is asking now. So if it was min heap, then first element should be minimum 11. So 11 is nowhere. Max heap, so maximum element is 131, so this will be max heap. So just convert in max heap. So for converting in max heap, root will be larger than its child. Okay, so here This will be 131, this will be 11. This is satisfying. 131 is larger than 11 and 44. Here this is not satisfying. 131, this will be 101. Now it is satisfying. 101 is greater than 11 and 44. 111 is greater than 90. 131 is greater than 111. Here it is satisfying already. 90 is greater than 75 and 33. But this root is not satisfying. 131, this will be 82. But now here 82 is smaller than 111. So this will be 82, this will be 111. So 111 is greater than 101 and 82. But here 82 is smaller than 93. So 93 will come here. Now see here. 131, 111, here 90, 75, 33, and this is 101, this is 93, this is 11, this is 44, this is 82. So first three element is 131, 111, 90, 131, 111, 90, D option. Now see this question. Consider the following recurrence relation. Which one of the following options is correct? So this recurrence relation is Tn equal to root under n, T of root under n plus n for all n is greater than 1, 1 for n is equal to 1. So see, we will solve it using Master's theorem. At first, bring it in the form of Master theorem so that we can apply here. So Tn has been given root under n, T root under n plus n for n is greater than or equal to 1. What I will do, I will take the value of n equal to 2 to the power k. So T of 2 to the power k is equal to root under n will be 2 to the power k by 2, 2 to the power k by 2 T 2 to the power k by 2 plus n is 2 to the power k. I can take what, just divide both sides by 2 to the power k. So this will be this side T 2 to the power k by 2 divided by 2 to the power k by 2 plus 1. This side same will be T 2 to the power k divided by 2 to the power k. I take this one y of k. Okay, so this will be y of k by 2 plus 1. See, 2 to the power k by 2 to the power k is by 2 to the k. So T of 2 to the power k by 2 divided by 2 to the power k by 2, this will be by k of by 2. So now this is in Master theorem. We will apply here Master theorem. So here a is 1, b equal to 2, like the form of Master theorem a b take now. What is t and like a t n y b plus f of n. So a is here 1, b is here 2. So what is the value of log of a to the base 2? Log of 1 to the base 2, this will be 0. So here n to the power 0, this will be 1. So we will have to multiply log of times. So its complexity will be order of log k So yk is order of times log of k, and what is the value of yk? Yk we have taken 2 to the power t of 2 to the power k divided by 2 to the power k. Okay, so this will be t of 2 to the power k divided by 2 to the power k is equal to log of k times order of log of k times. So t of 2 to the power k, this will be order of 2 to the power k log k times, and initially we have taken n equal to 2 to the power k, so k equal to log of n. So t of n will be order of 2 to the power k n and log of k, so log of n, k value is here log of n, so its complexity will be order of n log n, so n log n, so a option. Next, consider a binary mean heap containing 105 distinct elements. Let k be the index in the underlying array of the maximum elements sorted in heap, the number of possible values of the k. So let k be the index of the maximum elements stored in the heap. Mean heap, so for mean heap maximum element will be in the roots. Okay, the number of possible values of k. So for any tree, its internal nodes will be internal nodes, number of internal nodes will be total nodes divided by 2 to ceiling, so 105 by 2, 52.5, so its value will be 52. So number of leaves will be 105 minus 52, this will be 53. So total number of leaves will contain the maximum element inside mean heap, so 53 will be its answer. Next, see the symbol indicates functional dependency in the context of a relational database. Which one of the following relational is true? So we have to, in this implementation, we have to check which one is satisfying or not. So see first option, xy implements to zw, then it is telling x to zw. Actually here from x by we are going to zw, so we can't go from x to zw, this is false. Next option is xy to zw, then it is telling xy to z, this is true. Why? Because from xy we are going to z and w both, so we can go to z also. Next, xy to z and yw to y, then it is telling xw to z. So see, from x by we are going on z and from w we are going by, so we can write this one like xw to z, because from w only we are going to y na? So from xw also we can go to z, so this is also true. Next is transitive x by yz, then x to z, this is also true. So correct option are b, c and d. See this one, let G be a directed graph and T at DFS, a spanning tree in G that is rooted at a vertex V. Suppose T is also BFS, breadth first search tree in G rooted at V. Which of the following statement is true for every such graph G and tree T? So see at first the concept of back edge, cross edge, forward edge. So I have taken this graph for only showing what are back edge, what are forward edge, and what is cross edge. So in the blue color, this is simple graph 1 to 2 to 4 to 6, 1 to 3 to 5 to 7 to 9. So all blue colors are tree edges. So this back edge is from 6 to 2 and cross edge is this 5 to 4. So see, in back edge what it is happening, it is going from its node to its ancestor node, and in forward edge it is going to its descendant node. See, 1 to 8, so it is going to its descendant node, so this is forward edge. And cross edge, there is nothing common, neither ancestor node its descendant, so this is cross edge 5 to 4. So we have to find out if any a graph, if BFS and DFS both are same, then in that case which statement is true. Which of the following statements are true for every such graph G and T? T. So just draw a graph like this. A, B, C. This is T. One second. This graph is not like this. This is going from C to A, and this is from D to C, from E to C. So if we draw its BFS, what will its BFS? From A to B to D to C okay, and C to A. And here from E to C is also coming. So this is its BFS. So backage is possible here. So this is false. No, let me draw DFS also. So what will its DFS? At first we will go from a starting node to its till end, where we end B to D. This is last. No, from D to C also. And from C to A, this will be its back edge. And from E, we are going to C. So see here, back edge, both DFS and BFS are here same. Back edge is possible. Cross edge. Cross edge, if there is no common ancestor or descendant. So for E and C, there is no common ancestor or descendant. So this is cross edge. There is no forward edge. Forward edge means from any node to its descendant node. So we are not going from directly any node to its descendant node. See, only edges in G are edges in the tree. This is also false. There is also back edge and cross edges. So forward edge is not here. This is the case of particular graph. We will have to draw any particular graph and then we will have to check. Okay, so this is correct option. See this one, consider the following read write schedule S over 3 transactions T1, T2 and T3 where the subscripts in the schedule indicates transaction ID like this. Okay, this is simple question. At first draw the transaction T1, T2 and T3. So first is RZ, WZ, RX, then RY, WY, then ry wx w by. So we have to check the order if it is possible in the following order or not for conflict equivalent. So see wz, it can come anywhere, no, t1, and for c t3 this is y only, y. So t3 will always come before t2. So a option is wrong. T3 has to always come before T2. So this is satisfying. See, T3 will always come before T2. And T1 can come anywhere because it is Z. So first possibility is T1, T3, T2. Next possibility is T3, T1, T2. And other possibility is T3, T2, T1. So see option, all three options are matching T1, T3, T2, T3, T2, T1, and T3, T1, T2. Next, in this question, consider the Boolean expression f of x, y, z equal to sigma 3, 5, 6, 7, which one of the following statement is correct. So we will have to draw the K-map for this statement. 2, 3, 4. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, x, y, z. So x, y, z, 0, 0, 0, 1, like this till 8. It will go. This is 0, which is 1. Z is 1, so 1. And then this is 2, 3, 4, 5, 6, 7. So 3, 5, 6, and 7. So this is sum of product. What is its value? F of x, y, z is equal to 3 pair x, y plus y, z plus x, z. So this is correct option. And other AB, this is sum of product. AB take POS form, then this will be 0, 0, 0, 0. So what is its value? 0, 1, 2, and 4. So product of sum will be this one, 0, 1, 2, 4. F of x, y, z independent of input by, can be make independent of input y, x, y plus y, z plus zx. Is there any possibility? No. If there was any possibility, then we have made here K-map, the grouping only. So neither y nor x. So both are false. So correct option are A and B only. Now see this question. Consider the following C function definition. Int f, int x, int y, for loop till y, and x value is here. Actually it can be written x equal to 2x plus y also. Return x. Actually see here, we can generalize this one. How many times this function is executing? By times, from 0 to, like if by is 10, this will be execute how many times? 10 times, but its value will be added from 0. So see at first option, x is equal to 20, y equal to 10. Then in first loop, what will be the value of x? 2 times 20. No, just don't take the value like this. X will be 2x plus y. Sorry, 1 second. 3, 2, 1, start. So now x will be 2x plus y. For I equal to 0. If I equal to 1, then x will be 2x plus y. So previous x is 2, 2x plus y plus y. Its value will be 4x plus 3y. I equal to 2. X will be 2 times 4x plus 3y plus y. This is 8x plus 7y. In the same way, see, this is what, 2 to the power 3x plus 2 to the power 3 minus 1 by. Okay, so how many times this loop will go? Till 10 times y. Actually, this is 1 time, 2 time and 3 time. So this will go till 10 times. I equal to 9. Okay, so in that case, this will be 2 to the power 10x plus 2 to the power 9 by. Okay, and what is this 10 and 9? This is the value of y na. So if we generalize this one, this will be 2 to the power y x plus 2 to the power y minus 1 y. This is generalized form. So now we can compare from here for all the conditions. Okay, so first option, 2 to the power 10 x is 20 plus, or you just generalize this one more, 2 to the power y minus 1. So here 2x plus y. Okay, so just put the formula here, 2 to the power y minus 1. So 2 to the power 9, and 2x plus y will be 40 plus 10, 50. So this will be maximum value of 2 to the power 10 into 25. Greater than 2 to the power 20? No, false. Next, 2 to the power y minus 1, 2 to the power 19, 2x plus y, 40 plus 20, 60. So this will be 2 to the power 20 into 30. So greater than 2 to the power 20, yes. This one, 2 to the power y minus 1, 2 to the power 9, 2x plus y, 40 plus 10, 50. This is 2 to the power 10 into 25. 2 to the power 10 into 25, greater than, but it is telling less than. So this is false. Next, 2 to the power 20, just see its value, 2 to the power y minus 1, 19, 2x plus y, 20 plus 20, 40. So this will be 2 to the power 20 into 20, greater than. So this is also true. So true statements are B and D. So just generalize the formula, 2 to the power y minus 1, 2 to the power 2x plus y, and put the value of x by and check. So correct option are B and D. Let's see this problem. Let A be n into M matrix where M is greater than n. Which of the following statement is are true about the system of linear equations Ax equal to 0? There exist at least m minus n linearly independent solutions to this system. So at first consider any matrix. Let's consider A is n into M matrix. Okay, and here M is greater than n. So let's consider this is 2 into 4 matrix. Okay, and if x can be what 4 into anything 3, and then x will be its order will be 2 into 3. Okay, so uh, what it is asking, there exist at least m minus n linearly independent solutions to this system. So number of linearly independent solution will be n minus r. So n will be minimum of mn comma n. Okay, so here this will be minimum of 2 and 4. Sorry, m is 4, this is 2, n into m, no. Okay, well, let's take anything 4 or 2, so its minimum will be 2. Fine. And what will be its rank? Rank is less than or equal to minimum value, minimum of m into n. So here rank will be less than or equal to 2. So that means rank can be 0, 1 or 2. So in that case, number of linearly independent solutions can be number of variables minus. So here see number of variables will be how many? 3, no? See 2 into 3. Ax. What is x order? I have taken 4 into 3. No, just take 4 into 1. No, you can't take 4 into 3. X is variable, so its order will be 2 into 1. Okay, so number of variable is here 4. That means this is like this, no? x1, x2, x3, x4. This is X matrix. So number of variables is here 4. So number of linearly independent solutions can be 4 minus 0 equal to 4, 4 minus 1 equal to 3, or 4 minus 2 equal to 2. So it can be either 2, 3 or 4. So its minimum value is m minus n. So see, this variable is always will equal to m, and n is minimum value, so its rank, so this will be, that means minimum value will be m minus n. M is here number of variables 4, and n minimum value we have to take. It can be 0, 1 or 2. So accordingly its value will come. So at least it is taking at least m minus n. So here n is 2. See, n is 2. So its minimum value is 2. It can be 3 or 4 also, number of linearly independent solutions. Okay, so this is true statement. Next, there exists m minus n linearly independent vectors such that every solution is a linear combination of these vectors. Actually, this will be false because it is telling there exists m minus n linearly independent vectors, but it can be more than m minus n also. Okay, so from first statement only we can derive second statement. Here we have already seen minimum at least m minus n. It is telling exist m minus n. So this is false. Next is there exists a non-zero solution in which at least m minus n variables are 0. So we will have to take a case for these two options. For C, at first for option C, what it is telling, there exists a non-zero solution. Non-zero solution, okay, in which at least m minus n variables are zero. So we will take any matrix of order like I take 2 into 3 order matrix, okay. Here m is equal to 3, n is equal to 2, and it is telling at least 3 minus 2, that means one variable should be 0. So if I prove this false, then this will be false. So see, we will have to prove here false only, true it can be possible, okay. So just see the false condition. I take a matrix of order 2 into 3, 2 rows 3 column. Okay, 105, let's take. Next, I just take any case, later I will see 006, 2 rows 3 column, okay. And x, this variable will be 3 variable x1, x2, x3, 3 into 1. So x will be x1, x2, x3, so that ax will be of order 2 into 1, okay. So just multiply and see, and we will have to put it equal to 0. So if we multiply ax, first one will be x1 plus 5x3, next will be 6x3, we will put equal to 0 here. So it is going to x3 value 0. So what I do, I just put some value here, so it does not go to 0, or 2 value we can put also, no, because 2 is always 0 here going. So like this 016, so this will be x2 plus 6x3. From here we can calculate the value of x1, x2, x3 in terms of some variables. So first equation, this is second equation. From here x3 equal to minus x1 by 5, and here x2 is minus 6x3, so this will be minus 6x3 value is minus x1 divided by 5, so this will be 6x1, 6 by 5x1, okay. So see, all value are in terms of x1, so x1 is minus 1 by 5, x2 is 6 by 5, and x3 will be 1. Actually we can multiply here x1, so we can take some value k here, so minus 1 by 5, 6 by 5 and 1. So see, here no variable is 0. So what it was asking, there exists a non-zero solution in which at least m minus n variables are 0. So see here, non-zero solutions are all, but here no variable is equal to 0. So this statement is also false. There exists a solution in which at least n variables are non-zero. N variables are non-zero. At least this is telling. So let's take another example for this one also to understand. I take a matrix A, 3 into 4 order, okay, 1 0 0 0 1 0 0 0 1 0 0 3, and x will be 4 into 1, x1, x2, x3, x4. So just multiply x, this will be 3 into 1 will be x1, and this will be x2, this will be first row, second row, third row, x3 plus 3x4 equal to 0. So x1, x2 0, x3 will be minus 3x4. So we can take in matrix format like this: x1 0, x2 0, x3 is minus 3x4. In terms of minus 3, this one 1. We can take anything common at the place of x3, x4. So see here how many zeros are there: 2. And here n value is 3. So what was our question? At least n variables are non-zero. So at least n variables are non-zero. That means there should be at least 3 non-variables 0. But here 2 non-variables are 0. So this is also wrong. No? We have to prove by any example this is wrong. See this question 50. Consider a 5-state DFA aim accepting the language LM. This is LM is the subset of 0 plus 1 to the whole star shown below. For any string W 0 1 plus to the whole star, let n 0 W be the number of zeros in W and n 1 W be the number of ones in W. So this is the diagram of the DFA. Here it is asking which one of the statements are false. States 2 and 4 are distinguishable in M. So see, what is final state? I just separate final and non-final state. Final state is 1, non-final state is 2, 3, 4 and 5. I will divide in 0 and 1 what is its behavior. So 1 at 0 goes to 2. 1 at 1 goes to 4. So okay, for 1 done. For 2 at 0 goes to 3. We change the color. Sorry. For 2 goes to 0 on 3. 2 at 1 goes on 1. Okay, for 2 done. For 3 at 0 1. 3 at 1 2. Okay, for 4 4 at 0 1. 4 at 1 5. For 5 5 at 0 4. 5 at 1 1. So see here the behavior which can be equivalent by looking this diagram. Just compare. No need to compare one. This is final state. This is separate group. What it is asking 2 and 4. Just compare 2 and 4. 2 at 0 on going on non-final state. 2 on 1 going on final state. Okay, now 4 on 0, 4 on 0 going on final state. 4 on non-zero, 1 going on non-final state. So see, this is distinguishable because here final and non-final. So this is true statement. This option is not possible or false. Next option 3 and 4. 3 and 4. 3 on 0, final state. 3 on 1, non-final state. 4 on 0, final state. 4 on 1, non-final state. So see, this is not distinguishable. That means this is distinguishable. This is distinguishable. States 3 and 4 are distinguishable. This is wrong statement because this is non-distinguishable. We can combine both states in a single state. Next 2 and 5. 2 at 0 going on non-final state. 2 at 1 going on final state. 5 on 0 going on non-final state. 5 on 1 going on final state. So this is also non-distinguishable, but here written distinguishable. So this is also false. Okay, just draw its diagram. We will combine these states. So 1, this is final state. 3 4 and 2 5 we have to combine. 3 4 and 2 5. Okay, this is a starting state also. So for 1 on 0, going on 2. 1 on 0 going on 2. See, 1 at 0, no sorry, 4. 1 on 0, here see na, 1 on 0 going on 4. Sorry, 2 it was right na. 1 on it's going 4. Okay, this is 0, this is 1. Now check for 3 and what 4. 3 on 0 going on 1, and 4 also on 0 going on 1. See, both behavior will be same. 3 on 1 going on 2, and 4 on 1 going on 5. So 2 and 5 are in the same group. So 1. Now see 2 on 0. 2 on 0 it's going on 3. 2 on 0 it's going on 3. See, 5 should also go to 4. 5 is also going on 4 0. Okay, 2 on 1 going on 1. 5 also on 1 1. So like this. Okay, so this is the final diagram. We have merged both the states. So what is the last option? Any string w with n number of 0 in w equal to number of 1 in w is in this machine lm, this language. So see here, all 0 and 1, this is starting with 1 then ending with 0 here, or ending with 0, and it's continuous. You can't take any case where number of 0 is not equal to number of 1s. So this statement is true, so this is not false. You can compare and check any condition by taking any case. Let's say this question 51. The chromatic number of a graph is the minimum number of colors used in a proper coloring of the graph. Let G be any graph with n vertices and chromatic number k. And which of the following statement is are true? So first case is true statements. G contains a complete subgraph with k vertices. So what is subgraph? Subgraph is subset of another graph sharing some or all of its vertices or and edges. So if any graph has 4 edges and 4 vertices, then its subgraph will be 3 edges and 3 vertices also. So first statement, see here n vertices and k chromatic number. So n vertices, we can take any condition here for putting it false. Odd vertices, cycle graph 3, 1, 2, 3, 4, 5. Okay, so what will be its chromatic number? This red, this yellow, this red, this yellow, but we can't take red and yellow both, so black. So here chromatic number is 3. We have to take its subgraph. So just take this graph, take this graph. Here if we take any 3 vertices, its subgraph like 1, 2, 3, 1, 2 and 3. This is not complete subgraph because all vertices are not adjacent to each other. For complete subgraph, its vertices will be adjacent to each other. So this is false. G contains an independent set of size at least n by k. So see if there are k colors. So there will be k color classes and n vertices. This will be k colors classes. Okay, then one color class will have at least its size n by k. So for one color class, its size will be n by k, at least n by k. You can understand by pigeonhole principle. This one, G contains at least k into k minus 1 by 2 edges. So if there are k chromatic number, then its simple formula is kc2 edges. So you can find out this will be k into k minus 1 by 2 edges. This is also correct. G contains a vertex of degree at least k. So this statement is false. We just take an example. A cycle graph with odd vertices. Its chromatic number is 3, but its degree is 2 only. So at least k this is telling. So this is also false. See degree of any vertices. This is 2, but here chromatic number is k. Next is this question number 52. Consider the operations. This is operation symbol defined by I read this rhombus. Okay, a rhombus b equal to a plus 2b, and this is a square a square b equal to ab for positive integers. Which of the following statement are true? So this one we can take by any example. Associative law. Just see if this is following associative law or not. So what will be rhombus c, b plus 2c. This will be with rhombus a. Its value will be a plus 2b plus 4c. But if I take a rhombus b at first, then rhombus c, then its value will be a plus 2b plus 2c. This is not equal now, so this is false. For a square, you can see this is simply multiplication, it follows. No need to check. Operator, rhombus over the operator, a square over the distributive law. What is distributive law? Like we know a into b plus c, then according to distributive law, we distribute like this, no, a b plus ac. This is multiplication. So accordingly, just take an example. At first a rhombus b square c. What will be its value if we solve bc? and after solving this will be a plus 2bc, and according to distributive law this should be a rhombus b square a rhombus c. So its value will be a plus 2b into a plus 2c. You can calculate, both are not equal, so this is false. Operator a square over the operator rhombus obeys the distributive law. This will be true. You can see a rhombus a square b rhombus c. If we solve this one, this will be a into b plus 2c. This will be ab plus 2ac. Okay, b rhombus c b plus 2c multiply. Then according to distributive law, its value should be a square b rhombus a square c. If we solve this one, this will be ab plus 2ac. Both are equal, so this is correct statement, true. So option b and d are correct.